Okay, so I'm going to start by finishing the 3.1 that we covered in class. Just kind of review what we did here. Um, so we were graphing these parabolas right here, and the main thing is we got to find the vertex, the x-intercepts, and then there were a couple extra things we found. We found the axis of symmetry and the y-intercept, and so and then we also would find the range and stuff like that. And so we had these in two different formats. So the first format we looked at was the standard form or vertex form, and that was kind of what y'all were used to when we were using transformations. And I told you, if you wanted to use transformations, that's fine, but we did a little bit more in depth in class. And then the second type is when we're in general form, and that's where it looks um, more more like when we're factoring and stuff. And if I remember right, we had a little typo on, oops, a little typo on this one. It should have been a -8. But anyways, um, and so to find the vertex, we had to use this formula right here to figure out the x value. And then once you figure out the x value, you could plug it into the equation to figure out the y value. And then we had to factor it to figure out our x-intercepts. And so that's what we're about to do here. So these are the ones we already did yesterday that were in vertex or standard form. And now we're going to try these that are in general form. These are the last two that we didn't get to yesterday. And so I'm going to start here with listing my values. So this is my A, my B, and my C. And oops. And so then now the formula for my x value of my vertex is negative b divided by 2a. So let's see, that's going to be -6 divided by 2 times 1, which would be, oops, which would be -6 divided by 2, which is -3. So that is the x value of my vertex. And so I just use that little formula there to find that. And then so I have half of the point, right? To find the other half, you just go ahead and substitute that value for x. So I'm going to evaluate the function at f of -3, and that will give me the y value. And so let's see, we're going to get -3 squared plus 6 times -3, and then plus 8. And then let's see, -3 squared, it becomes +9, then plus -18, and then plus 8. And so let's see, we'll add all this together. So let's see, that will give me, what is that? That's -9, and then -9 plus 8 is -1. -1 right there. And so that would be the y value of my vertex. So my vertex is located over here at -3 down 1. So there's my vertex. And then I know it opens up because my a value is positive. So I know it's going to kind of look like this. And so now I need to figure out my x-intercepts. And so we got to go ahead and factor this. And so, oh yeah, I'll just go in order. So let's see, axis of symmetry would be x equals -3. It's always going to be the x value from the vertex. Now we're at our x-intercepts. So let's go ahead and do that. So let's see, x-intercepts, by definition, to hit the x-axis, I have to let y equal 0, or in this case, we're using function notation, let f of x equal 0. So I'm going to set that equal to 0 and factor it. So let's see, I'm going to have x squared plus 6x plus 8. I'm going to set that equal to 0. And then this would factor into x plus 4, x plus 2, right? 4 times 2 is 8. 4 plus 2 equals 6. So I know those are my two factors. And then when I solve them, let's see, scroll down a little bit. When I solve this, when I'm trying to figure out what values of x make this equal 0, this one would be a -4. That would cause that to 0 out. And this would be -2, would cause that one to 0 out. So my x-intercepts, so I'm going to go ahead and list them as ordered pairs, would be at -4, 0, and at -2, 0. So let's see, -4, 0, -2, 0. That looks pretty good. And then the y-intercept on this is actually fairly simple when it's in this format, because it's just going to be the c value. Because if we're looking for my y-intercept, this time by definition you let x equal 0. So we're going to evaluate the function at f of 0. And so let's see, we're going to have 0 squared plus 6 times 0, and then plus 8. And so what happens is, 0 squared is 0, 6 times 0 is 0. I'm left with just the 8. So when I let x equal 0, y equals 8. So that's going to be way up here at 0, 8. And then if I were to put the line of, or the axis of symmetry, I could reflect that across, and I could find an additional point over here. Now, really, you only need about 3 points or so, and on your homework, it's only going to take 2. On your homework, they're going to want you to put the vertex in either of the x-intercepts, and the graph will just pop up on there for you. So that should be fairly simple. And then, let's see, then we're asked for the range. And so let's see, it goes from, looks like -1, and then goes up to infinity. And then they will ask you for the domain on the homework, but I don't put it here because it's always from negative to positive infinity. It goes left and right indefinitely, so I don't include that as a question on my notes or on the exam. Okay, let's see. I've got one more like this, and then let's see. Okay, here we are. So part D, my last one. Okay, so let's see. Let's start with the vertex. So the x value is going to be -b over 2a, and my a value is -1, my b value is 2, and my c value is 3. So let's see. This is going to be -2 over 2 times -1. So when I simplify that, I'm going to get -2 over -2, which simplifies into a +1. So I figured out my x value. Now I got to figure out the y value. So now I have to plug 1 into the function. So f of 1. So I'm going to have negative and then 1 squared. So be careful, the negative is applied after the power. Then let's see, plus 2 times 1 and then plus 3. Well, let's see, well, I'm not going to worry about that. I'm going to square it first, and then the negative gets applied. So that turns into a -1. So 1 squared is 1, but then the negative will apply in a moment. Then let's see, then we have plus 2 plus 3. So when I add this all together, let's see, that will give me, what is that? That's +1. And then let's see, then we'll go ahead and add that together, and that'll give me 4. So I'm going to be at 1, 4, over 1, up 4, so I'm up here. And then I know this time it's going to open down because my a value was negative this time, so I open down. Axis of symmetry would just be x equals 1, and so that's just this line that's going to cut this in half. So if I find any point, I can reflect it across that axis of symmetry right there. And then for my x-intercepts, so x-intercepts, we're going to let the f of x equal 0. So we're going to set this equal to 0. So we're going to have negative x squared plus 2x plus 3 equals 0. Now, we had a problem like this yesterday, and you can factor it in its current form, but I would not recommend it. What I would do is I would just go ahead, and one of my properties of equality is I can multiply or divide both sides by a common value, and I still preserve the equality. So what I'm going to do is I'm going to divide both sides by -1, and what it does essentially is cause a sign change of everything that I have here, except for 0. 0 will just stay 0. And so now that's something I'm a little bit more familiar with, a little more comfortable with. So now I'm going to go ahead and factor this. So let's see, what multiplies to give me -3, but will add up to -2? Well, let's see, -3 times a positive 1 would give me negative 3. And then those two numbers would also add up to negative 2 right there. So this is it in factored form. And so now I'm trying to figure out what makes each factor equal 0. And so on the first one, that would be a positive 3. 3 would make that equal 0. And then on the second factor, what would make that equal 0? That would be a negative 1. So those are my two x-intercepts. So I have one at 3, 0, and I have another one at negative 1, 0. And so I'm going to go ahead and plot those points. Let's see, 1, 2, 3 right there. And then let's see, negative 1, 0 right there. Okay. And then for my y-intercept, that should be pretty simple. It's just going to be that 3 right there. Oops. It's just going to be that 3 right there, because when I do f of 0, everything's going to zero out except for that 3 that's on the back end. So when x is 0, y is 3. So that's going to be my y-intercept at 0 up 1, 2, 3 right there. And if I want to, I can reflect it across to get an additional point. And here we are. So we'll just kind of draw this with a smooth curve going down. Smooth curve going down. And so my range this time, you got to be careful. You got to go from bottom to top. So it's going to be negative infinity all the way up to 4. Okay, so that is finishing up what we started yesterday. And so what I'm going to do is I'm going to go ahead and make an additional video for the next section, and we'll just kind of go from there.